Hi all, this is Honey. Welcome back to our channel Code with Honey. Today we are going to solve September day 1 LeetCode challenge, which is maximum average pass ratio. So what they are stating in this question. So there is a school that has a classes of students and each class will be having a final exam. So they will be giving us a 2D integer array which will consider how many people got passed and total number of students. So we know the beforehand that in the classes of I there are total students which is total of I, but only pass of I is the number of students will pass the exam. So they also given us extra students which are so brilliant, okay, so that are guaranteed to pass for sure. Okay, if you assign them to any class, they to that class you can assume that they will get passed no matter what. Okay, so what they are telling, we want to assign the extra students to a class in a way that maximize the average pass ratio across all the classes. Okay, the pass ratio is nothing but number of the students of the class will pass divided by total number of the students. Average pass ratio is total sum of the pass ratios of the all classes divided by total number of the classes. So we have to return the maximum possible average pass ratio after assigning the extra students. Okay, so answers will be within 10 to the power of 5. The actual answers will be expected. Okay, so here they have given this class. Okay, one out of 2 students, 1 student got passed. Here out of 5 students, 3 students got passed. 2 students out of 2 students, 2 students itself got passed. So now we have to assign this 2 to extra students to any of these classes. Okay, so that we will get the maximum average pass ratio. Got it? So here it seems like they have added the 2 students itself to the class 1, and that is giving us the maximum average pass ratio 0.78. Okay, so yeah, it's not like always you have to assign the extra students to the same, all the extra students to the same class. It depends on, if you add one extra student you have to see how much pass ratio is getting increased. The same way you have to do the second time, the same way you have to do till you have to keep on assigning one student to the each class, and you have to see which is having the maximum pass ratio, then you have to assign the next one student. Like that only we can figure it out the maximum possible average pass ratio. Got it? So in this what we are going to do is, first we know, okay, this is the classes and these are the extra students. So how will you basic approach, what we will be thinking, okay, we'll assign one student, we'll figure it out what all the pass ratios, and we'll be assigning one student to the class, and what will be our gain will be nothing but your current pass ratio and your updated. If you are adding one student to this class, what will be your updated pass ratio? So if you find out the difference, you will be getting the gain. So by adding one student to this and this and this, then we will know which classes is giving us the maximum gain. Okay, we know the pass ratio already, and by adding one student you know what will be your updated pass ratio. If you subtract the current pass ratio and previous pass ratio, you will get the gain, right? So we have to generate a maximum possible, right? So which is having the maximum gain, that only will be taken into an account, right? Yeah, this is the basic approach that we are going to implement for this question. So yeah, let's take a look. The same way for this, we can't, these sort of examples we can't explain in a verbal way. It's better to look it out how we are going to implement this. Got it? This is the classes that they have given, and these are the extra students. Okay, now we wanted to return a maximum average, right? So maximum average will be, how will you assign one extra student to which class we will you assign? So what we will be doing, first we will be having this pass ratios. Got it? So that will be 0.5, 0.6, 0.1. So by adding a new, now I have two extra students. First I'm adding one extra student for this, which is 2 by 3. If I add this to this, if I add to this, I'm getting this as a pass ratio, which is updated pass ratio. Now to whom I will append, uh, to whom I will give the extra student, that how will I figure it out? Okay, 0.5 minus 0.6 gives you 0.16, right? For this 0, for this also 0. So by adding one extra student gains the first class, okay, not second or third. So what we will be doing now, we will be getting updated this our new class ratio, parent ratio, she pass ratio, our new pass ratio will be got updated to 0.66, 0.6 and 1, because I added one student to my class 1. Okay, now the classes of this will get updated to 2 comma 3, right? Okay, now the next one extra student would have got removed. Okay, now for this extra student, the same way you will be trying to add it to the each class. Now 3 by 4 will 4 by 6 and 3 by 6. Again you will get new pass ratio 0.75661. So now what will be our maximum gain? Okay, if you subtract 75 and 66, what we are getting? We'll be getting 0.1, 0.9, right? Okay, this will be 0.9 and this will be 0.661. 0.66 minus 0.6, 0.6. 1 minus 1 will give you 0. So our maximum uh, whose average is getting increased by, so we have to put a maximum, right? So what we will be doing, so now this only gets maximum. Now our updated pass ratio will be 0.75 and we have updated to 34. Okay, now these are the pass ratios and we have updated the class as well. Got it? 3 comma 4. Okay, now this is how we will be doing, right? 3 by 4, 3 by 5 and 2 by 2. Okay, whosoever the pass maximum, they are getting the maximum gain, who that we will be updating into the pass ratio, and their corresponding classes of passes will get increased and the total also will get increased. Now we have this pass ratio. Now we'll be basically adding all these things will get 2.35 and now we are dividing, will be getting 0.75. So only one thing we have to taken into a consideration, like, so we have to increase the maximum possible ratio. So how we will increase? So by adding one student who is getting more benefit. Okay, by subtracting the previous pass ratio and the current pass ratio, we know, okay, this particular class is getting more benefited. So then only you can update the extra student, right? You can't blindly go and update anyone. Okay, like this only will be doing. This is the exact same, this is the exact same approach that we have used to solve the given question. So see, for each, initially we will be storing the pass ratio. Pass ratio is nothing but class of 0 divided by class of 1. See, we are doing and storing, appending it in a pass ratio. So we will be getting this as a pass ratio. So now we will be traversing through each extra student. So now the extra student will be 2, right? So when it is 2, now you will be getting, by adding it to 1, 1. Now you will be getting updated pass ratio. So 2 by 3 will give you 0.66. This is our updated pass ratio. Now we wanted to find out the maximum gain. How will you find out the maximum gain? So we'll be traversing through all this updated ratios and you will be keep on subtracting this minus this minus this, which is coming the maximum, that index as well as the maximum gain we will be taking. Okay, to pick out the chosen class index. Once you chosen the class index, now what you have to do, you have to update this ratio, right, to get the final answer, sum of all the past ratios we will be doing, right? For that we are updating that, and our classes of chosen class index will get updated to 2 initially, here 3, right? Yeah. Next, the same thing, now the extra students will get updated to 1, right? So for this also the same thing we'll be doing now it's 2 and 3, now we'll be getting 3 and 4, and the updated ratio will be 0.75. Now the same 3 by 5 will be adding 4 by 6 only will get added, because that was not the extra students index, right, last time. So it will be the same 0.66 and the 1. So now if you see among this, if you figure out the distance difference again, 0.75 minus 0.66, okay, now this is giving 0.9, which is greater than already existing. Already existing is having more, by adding one extra student doesn't have any difference to other two classes. This only has the maximum difference, so we will be updating again to the index based on the maximum gain of the pass ratio and our current pass ratio. Okay, then now we'll be getting the, obviously we'll be getting the maximum pass ratio, so that we can, when you are dividing, you will be getting the maximum average pass ratio. Got it? But if you run through this, if you use the solution and if you run through, it will go into a time limit exceeded, because for each extra student we are running n times the updated ratios, right? Every time you are running the each class and you have to figuring out, okay, which is the maximum gain. So for sure you wanted only the maximum gain, right? How we can fetch the maximum gain? By we have to, if we store these differences in a heap, and if you fetch the maximum value from a heap at order of log n, okay, so you can avoid traversing through n times, right? So that's what we are going to do. Instead of this, we are going to use the max heap function. So for sure our extra students will be 1, right? So now, so for sure our extra students will be 1. So what we are going to do in when you are traversing for the first time itself, if you, this is the gain formula. So what is our here updated ratio is nothing but +1 +1, and you are subtracting the pass ratio. Pass ratio is nothing but passed students divided by total students. So what we are doing, this we are basically we are storing it in a max heap, so we are doing that. So you are just created a function called gain that will return you the gain. So that's what we did here, right? So what we will be doing, once you divide the new extra after you adding the extra student, if you subtract this updated ratio and previous updated ratio, which is giving a maximum gain, that only you are going to take. So if you store it in a heap, okay, so whenever you are fetching that heap, it is going to give you the gain as well as the number of passed students and number of the total students. So initially we need to store one, for example, what will be our heap now looks like when it traversed, it will be minus 0.16 1, 2, minus 0.6 3, 5, minus 0, which is 2, 2. So this is how our heap looks like, 0.66, because after we have added one extra student, for sure minimum one extra student will be there, okay, that's how they have stated. So 0.66 minus whatever comes we have stored, and the corresponding, what is the past student, total student. So we have stored that. Now we, our extra student will be ranging from 0 1. When I equals to 0, our current gain will be, what will be our current gain, which will be getting 0.16. Our past student is 1, total student is 2. This is the first gain if you're increasing the one extra student. Okay, for the first extra student, my gain is 0.16, and their past student, previous past student, and Okay, now what we will be doing, now if you add one more, so whatever the maximum only we would have taken, right? So now if you add one more student, how much you will be getting it with the 0.16, so that you will pass to the gain. Okay, now what gain will do, so gain will be like, now increase, already past student is here 1, right? So here it will be 2 comma 3, it will pass. So here it will be 3 by 4 minus 2 by 3. Now it will give you what, 0.9, which is as we discussed here. So here 0.66 is the new updated one minus 0.75. Once you got that, now our 0.9 will get updated right here. Now instead of 0.6, okay, 0.9 comma 2 comma 3 was the previous past students and totals. Now 1 will go, okay, and still it will get updated this one. Now which is the maximum, again 0.9 is the maximum. Now so here it will come now 2 comma 3, so which is here also 3 comma 4 will go. Now it will go 4 by 5 minus 3 by 4, right? That was the current past students review. So 4 by 5 is nothing but 0.8 minus 0.8 minus 3 by 4 is 0.75. Okay, now we will be getting 0.5. Okay, now our 0.9 would have popped out. 5 comma 3 comma 4, that's what we are pushing into the heap, correct? 3 comma 4. So why you are traversing till one extra loop to get your accurate parent? For here calculating this past students by total student, we need is the previous one, right? Yeah, so yeah, that's why we are initially we have to store the current gain to start with the highest value, to start with the maximum gain. That's why we are storing current gain and our past students comma total students. Yeah, that's it. Now you know by doing, see, you will be getting 3 by 4 will be giving you, that's what we would have calculated. 3 by 4 will give you 0.75 and 3 by 5 will give you 0.66, 2 by 2 will be. So that's what we having at the end. So 3 by 4, 3 by 5, 2 comma 2, that you will be doing that, and you are updating the pass ratio, and total pass ratio will be whatever the total pass ratio divided by number of the classes, if it is 3 or 4, whatever it is. Yeah, so by this what we are doing, instead of traversing order of n to figure it out the class again, another n to figure it out the maximum gain, we are just using the first, at first we are using what, our current gain, right? So based on that we will be what is coming maximum from this current gain, we are storing it in a max heap, right? Based on keep on popping it out till the number of extra students, we are keep on adding it to the current gain, and we are subtracting the previous ratio and the current ratio, so that we'll know what is the gain, so we can add to the max heap again. So whatever the maximum value, will be fetching it out, and the corresponding parents will get added 1. I hope this makes sense to you guys. If you now the time complexity, let's discuss the time complexity and space complexity. So for this, the time complexity will be, let's assume the extra student is k. So k star, you have to traverse n classes every time. So k star n you will be doing, okay. And but for this, now this is approach 1. For approach 2, now we'll be just traversing through the fetching from what heap. So which means first you have to put it into the max heap, which is k log n plus n log n. For now we have to keep on, so n log n is for putting it into the all the gain values into the loop. Now k is nothing but extra students. To pop it out every time and pushing it back will be like order of log n operation, so that's why we'll be traversing through k log n. And yeah, max save or here pass ratio, updated pass ratio will be having order of n, which is common for both the approaches. Yeah, I hope this makes sense to you guys. If you still have any questions or concern, please do leave a feedback in the comment section. I'll be checking it out and improve myself better for the upcoming videos. Yeah, if you do like my video, please like, share and subscribe. I'll be providing the GitHub link to the solutions in all the languages. If you still have the question or couldn't understand something, you can go and check it out and try to debug it on your own. I hope you will solve this question today and you will have the streak. Yeah, thanks for watching.